Good evening, and welcome to the Xander Show. I'm your host, Pat, and tonight we have a special discussion on SPDEFs with my colleague, Alazar. So, how you doing today?
I'm alright, thanks for asking.
Yeah, what lovely weather here, huh?
It's a wonderful evening.
So, on the topic of SPDEFs, we wanted to get a distinction between something that is not known in prostate cancer to the general, population in terms of known knowledge. So, what is the exact distinction between SPDFs and PDEFs?
Right, so let's start off with the whole idea that SPDF and PDF are actually only proteins, okay?
Mm-hmm.
They're said to be one of the derivatives that cause prostate cancer as they regulate either higher or lower in terms of levels of SPDF in the body. So what we're looking at here is SPDF and PDF are essentially the same thing, just different derivatives of the name. In the late 90s, when it was discovered by a group of scientists over at Boston Medical, right? But when they discovered it, it was actually known that it was called PDF, which is prostate-derived ETS factors. Okay, and then over time, as they realized that the structure was actually a little bit more different than what they originally assumed, but it still doesn't mean that they did not coin the same name. So they coined it, SAM-pointed derivative SPDF. So which is why they call it SPDF, because there's always that SAM-pointed derivative ETS factor.
What's interesting to me is that it said that there was damages within scar tissue in the area of, that there's also indications that there's scar tissue also in normal and prostate cancer.
So SPDF is known to be, in the discovery of it, they said it's prostate-derived, correct? So even in the prostate derivative of this SPDF factor, we have to consider one other aspect as well. Yeah. It can't just be the prostate, which is why you have to consider epithelial cells as well. And this is a whole different lining of cells. It's not just the prostate area. So we're looking at epithelial cells and kind of just deriving it off of that. And they're going into discussing what epithelial cells look like and how they structure. And now, I don't know if you know this, but epithelial cells are everywhere in your body. We're looking at between tissues, in between stomachs, scars, everywhere. Okay? We're looking at liver, kidneys. We're looking at your cells just on top, below, layers. Okay? Skin. Excuse me. Skin even has epithelial cells in it.
Epidermal layers.
Epidermal layers, right.
Yeah. It's a Latin prefix. Now, what is interesting to me is that in a normal prostate, there's NKX 3.1, and there's low to no any inclination of there being any NKX 3.1 present in an actual prostatic cancerous tissue, if you will, or body of cancer. So why is that? And does it have anything to do with the AR target genes or enhanced coagulation?
Let's redefine some of the terms you have going there. This is just facing the public here.
Yeah.
So AR, androgenic receptors, right? Yeah. And then you have to consider other aspects when we're looking at SPDF specifically. We have to look at other target genes, other proteins. This specific protein interacts with a greater deal of other proteins. It looks into what seems to appear as not just prostate. Okay, it does everything but prostate. Okay, and then when they kind of focus it back to the prostate, we see a correlation between that and between other types of proteins that function in the body. Does that make sense?
It does, but it seems that the lack thereof of the AR receptor, and then plus that with PDF agent also is confusing.
Right. Yeah, by all means, I totally understand that. Even reading that article just seems very, very, very complex, and I understand that. But assume this. Assume an industry, okay?
Yeah.
There's an industry, and then you have certain products that need to go out of that industry, right? How do you get products out of an industry?
You have to have a market.
You have to have a marketing. And how do you market those things? You have a car. You have to travel those things, right? Those things need to be signaled out to other areas from the factory or from the industry, right? So how do you get that to coming into other areas? That's what the AR is like. The AR is essentially, right, that signaling marker that constantly is signaling other proteins and telling them, okay, this is active, this is working, this is not working. And it's very unique when you look at SPDF as well, okay? Because SPDF's interaction with NF-kappa B, which is one of those epithelial cell receptors, very well known, right? And then when you also look at it, you also have to know that GDP, right?
Yeah.
Growth factors, EFG, all those things matter when we're looking at SPDF because the intertwined angle of all these proteins and the specific SPDF protein is very, very likely to be known for that reason. It's that there's other interactions. It's not just the one thing that it does, essentially just being part of the prostate. It would kind of clarify that as no.
It definitely has a monumental role because if you have one or the other, one single on its own versus, them together, it's obviously going to be a difference. A recipe for disaster versus a recipe for health. So,
right.
Yeah.
If you've also read in depth of that same article that we were just discussing, which you guys can also find on the NIH website, this article actually specifically also looks at colon.
It was a pleasure having a discussion with you, and just want to say thank you for joining us.